Question number 3 on test review number 3. We need to find all real zeros for our function f of x, that is 32x fifth minus 40x to the fourth minus 12x to the third. If you notice, the degree of this polynomial is equals to 5. And we haven't learned any methods, direct methods, to deal with solving a polynomial equation of degree 5. So what am I going to do? Well, first, because I'm looking for the real zeros, I'm going to set f of x is equals to 0. That means 32x fifth minus 40x to the fourth minus 12x to the third is equals to 0. Now I'm going to look for ways to solve it. It is a degree 5, so quadratic formula is not going to work. AC method is not going to work right off the bat. So you always need to think of the very first step we always do. Is there a GCF? Is there a greatest common factor for our three terms? They all have x's. The highest degree of the x they have is to the third power. And all the coefficients are divisible by 4. So I'm going to say yes. The GCF is 4x to the power of 3. All right. So now I am going to go and divide every single one of these terms, all three of them, by 4x to the third. So that means I'm factoring out 4x to the third. And let's see what's remaining for each term when I divide 4x to the third out. 32 divided by 4 is 8. 5x's, 3x's at the bottom, so x2 left. Minus 40 divided by 4 is 10. 1x left on the top, minus the x to the third cancels. 12 divided by 4 is 3. That is equals to 0. All right. Now, when I look inside the parentheses, I see a quadratic expression. To solve a quadratic equation, because we want this to be set to 0, we can do it three different ways. We can use factoring, we could use square root property, or we can use the formula. Not all of them will work, so we have to find the one that works. Formula always works. I'm going to give the AC method a try. Looks like A is equals to 8, B is equals to negative 10, and C is equals to negative 3. We are going to look for two numbers because there are only three terms. I don't know how to factor by groupings with three terms, so we're going to look for two numbers that give us AC, which is 8 times negative 3, negative 24. A times C is equals to 8 times negative 3. It is negative 24. And they add up to the value of B, which is negative 10. Think of the factors of negative 24. 8 and 3, 6 and 4, 12 and 2. If 12 is negative and 2 is positive, that will work. That means I found my numbers to split up the middle term. So I'm going to rewrite this expression as 8x squared minus 12x plus 2x minus 3 is equals to 0. All right? Let's do it. Let's not forget, we still got 4x to the third in front. Now I'm going to use the grouping method because I got 4 terms created. The GCF for the first two terms is 4x. So I'm going to divide both of them by 4x. And the GCF for the second two terms, it's nothing actually. So we're just going to put a 1. All right, let's go ahead and finish the factoring piece. 4x, 8 divided by 4 is 2, 1x left, minus 12 divided by 4 is 3. X does cancel out. Plus 1. Do not forget to put the 1. It's very important you do so. All right, focus inside the parentheses. Looks like we did a good job because the common binomial, it's exactly the same. So next step, we got 2x minus 3 as our greatest common factor. When we factor out 2x minus 3, we get 4x left from the first term and 1 left from the second one. Let's not forget 4x to the third. Now that we got the complete factored form of this polynomial, we can use the zero product property and set each of the factors to 0. So we got 4x to the third equals to 0 if x equals 0. Why? Because if I divide both sides by 4, x to the third is equals to 0, which means x is equals to 0. 2x minus 3 is equals to 0, which means if I add 3 on both sides in order to solve for x, I'm going to have 2x is equals to 3. Dividing by 2, I get x is equals to 3 over 2. Here is my second 0. And then the next one is creating the last factor equals to 0. I'm going to minus 1 on both sides. I get 4x is equals to negative 1. Then if you divide by 4, we get x is equals to negative 1 over 4. So we got 3 real zeros for our function f of x. X equals 0, x equals 3 over 2, and x equals negative 1 over 4.